In this video, I'll be explaining what a Bezier curve is and how I have implemented it in my Paint program. So a Bezier curve is a parametric curve that is defined by a set of control points. Here we have P0, P1, P2 and P3, where P0 and P3 are the anchor points through which the curve passes, whereas P1 and P2 are the intermediate control points which affect the shape of the curve. So P1 and P2 can be moved around and manipulated in order to change the shape of the curve or how the curve flows. So a basic curve for these points where P0 and P3 are anchor would look something like this, where the curve passes through the anchor points and P1 and P2 influence the shape of the curve. Now moving ahead to the concept of linear interpolation, which is very integral in Bezier curves. Linear interpolation. So the idea of linear interpolation is that if you have an initial point, let's say P0, and a final point P1, so linear interpolation along the line P0 and P1 at, let's say, some variable t is equals to 0.3 would be 30% from the way from P0 towards P1. Now for t is equals to 0.5, it would be halfway through, that is 50%. And for t is equals to 1, it would be 100%. So this allows us to break a line or any line segment or a curve into a number of points. So for t between 0 and 1, I will get a number of points along these lines, and I can represent this line as a series of points. So that allows me to express my Bezier curve as a series of vertices or points rather than lines, which would be um, not appropriate in a sense. Now moving ahead, linear interpolation will be used a lot ahead as it is very integral and important. Starting off with the quadratic Bezier. As a linear Bezier is a simple line as shown, as just shown. A quadratic Bezier would look something like this. It will consist of 3 points, P0, P1 and P2. So again, P0 and P2 are the initial and final points that are the anchors, and P1 is the control point. So moving P1 would affect the shape of the curve, the bend of the curve, to be precise. So the curve will be drawn by linear interpolating. The vertices will be obtained by linearly interpolating between P0 and P1 and P1 and P2. So for t, let's say 0.5, we will get a point over here for P0 and P1, and for P1 and P2 we will get a point over here, which is B1 and B2. Now we will draw a line between B1 and B2, and we will linearly interpolate them as well with the same value of t, that is 0.5. So we'll get, finally we'll get this point, that is for t 0.5. we have this point V, that is the same as this. So for t which is between 0 and 1, we will have a number of points along the way, and we will obtain something like this, which if connected through a line would form something like this, which is the quadratic Bezier between P0, P1 and P2. Now moving ahead to the cubic Bezier, which consists of 4 points. Cubic Bezier which consists of 4 points, P0, P1, P2 and P3. For this we will quadratically interpolate between P0, P1 and P2, and we will interpolate between P1, P2 and P3 as we've done in the quadratic Bezier. just a while ago, and the points which were returned, which was B in that case, we will we will interpolate it among them, like between P0, P1, and P2, and P1, P2, and P3, with the same value of t for that specific point. So I will do it for a value of t, for one value of t. Let's say t is equals to 0.5. So we get a point here for P0, P1. We get another point here for P1, P2. Linearly integrate between them. We get this point. That is our point. Let's say V1. Now for P1, P2, and P3, we will get this point. This point linearly integrate between them, and that would be our point. So that will be V. That would be V2. Now for the quadratic Bezier, we will we just got V1 and V2, but for cubic we will connect these points and we will linearly interpolate them again 0.5. So that will be one of the points for the quadratic Bezier. So for t is equal to 0.5, we get V. That is this. So again, we will do it for t between 0 and 1 and get a series of points or vertices along these lines. When joining them, you will get something like this, which will be the cubic Bezier for the points P0, P1, P2, and P3. That is the mathematics behind the Bezier curve. So this is the Bezier curve class in my main program, which extends from the abstract shape class, from which all the other shapes that I've implemented in my program are being extended from. So the Bezier has a precision. This is 0.001. This is the difference between the value of t's, as I said, between 0 and 1. The vertices are all the vertices of the curve along which it lies, or the points basically. Now I construct the Bezier curve using a fill color which I get from the stroke color selected in my paint application, and I initialize the points as 4 because I'm going to draw a cubic Bezier in the end, which has a total of 4 points, and I'm initializing the vertices linked list, which is obviously the linked list containing all the points of the Bezier curve. Now in the draw function, I am first of all initializing the curve, because every time the curve is drawn, it should be initialized, which means all the vertices should be cleared, since moving a single point would mean a new shape is drawn. So I clear the vertices, and in the end I put a for loop for t is equal to 0 between 0 and 1, and I move the precision. Precision basically by how much each of my point differs or is like away from each other. So it gives an idea of precision or how smoothly my curve bends. So points one, if points one is null and point two is null, that is p1 and p2 are null, which means we just have p0 and p3. So a linear line is drawn between p0 and p3. I am linearly interpolating it here in the linear function. I'm linearly interpolating the value of x and the value of y and returning that point. So what I could have done here was I could have just drawn a single line between p0 and p3 using g2.drawLine or g.drawLine or anything, but because I'm expressing my curve as a series of points, so I've taken it in a uniform manner and I've done the same thing over here. So I've made the line as a series of points between p0 and p3 with the precision t, of course. So now the other case would be that I've clicked on the panel once and I have P0, P1 and P3, that is the anchor points and one control point. So in that case I will draw a quadratic between those 3 points. So in the quadratic function I'm linearly interpolating between P1 and P2 as I did earlier, and P2 and P3, and linearly interpolating between the point P1 and P2 I get by linearly interpolating between them. So this is the point P that I showed before. So I return the point b for every value of t, as there's a for loop over here for t0 to t1. Now in case none of these are null, which means point 0 to point 4, we have all the points. So I'll be drawing a cubic Bezier. So in this we will be quadratically interpolating between p1, p2 and p3 as I showed, and P2, P3, and P4, and the points that are returned, we will linearly integrate between them. So that returns us a point V. So that's the idea of how my quadratic Bezier goes about. Yeah. So in the panel, I'm monitoring the mouse presses and everything, and I am setting all the points by which my curve is drawn. So in this, I am checking if I'm within the drawing region, and if my shape choice is between 0 and 9, that is 1 to 8. Since I've got 8 choices for the shapes. Now, if shape choice is equals to 8, which means the shape choice for 8 is Bezier curve, so I'll go here, and if clicks is equal to 0, which means I'm in the initial phase where I haven't pressed even once. So a new shape will be made, which will be called which will be a Bezier curve, of course. And here I am getting the color from the stroke color button. I push the shape in the layer. I clear the redo list as I purge the redo list as a modification is made on the drawing region, or something is drawn. I set the stroke using the stroke toolbar by getting the stroke value from the stroke toolbar, and I set the points I set the initial point and the final point to where my cursor is clicked, the mouse is clicked or pressed. So I won't go into these since the clicks value is initially 0. Now the clicks value is incremented after I've pressed it once. So after I've pressed it once, I'm going to drag it, of course. So here I am dragging the Bezier curve. So if shape is equal to 8 and clicks is equal to 1, since I incremented the clicks, now the value for clicks is 1, and I set the final point that is at index 3. So I get a straight line out of P0 and P3. Now I will release my mouse, of course. So I'll go here, and I've set this special condition for the Bezier curve where if shape is equal to 8, that is it's a Bezier curve, and clicks less than 3. So as long as clicks are less than 3, I will return from this mouse release function, which basically ends my drawing. Drawing is default, as you can see in shape is equal to null, and it resets the clicks value and the shape choice value. So basically what I'm doing here is I'm resetting my entire shape. So it will return from here if the clicks are less than 3, so it won't go into this until the clicks are less than 3. So I'll go back into the mouse pressed. So this will go on for clicks equals to 1. I'll set one control point, the first control point, and I'll drag it. I'll set it again wherever I drag my mouse, and I'll return from here since the clicks are still not 3. Now finally, for the fourth point, I am setting a point at index 2, that is P2, and clicks are incremented here to click. Now the value of clicks is 3 after the statement. So when I drag it, when I so here I'm dragging clicks, the value of clicks is 3, so I'm setting the point 2 again, P2 again, and when I release the mouse this time, it won't satisfy this condition and it won't return. So now my shape will be, it will get reset. So after when I click it again, so a new Bezier will be drawn all over again, since the clicks will become 0.